Let's talk about relations and functions. A function is a relation in which each element of the domain or the x's, is paired with exactly one element of the range are the y's. In other words, the x's cannot repeat. So take a look at your screen. We have 1, 2, 3, 4, 5 ordered pairs. This is a relation. We're trying to determine the domain, the range, and whether or not this relation is a function. The domain are the x's. So every ordered pair is of the form x comma y. So the x's here are -4. And notice that I have two -4's. I don't have to write them twice. Then I have 5, -10, and 8. So 5, -10, and 8. And sometimes you're going to see that answers are written in order, in increasing order. So this, for example, would become -10, -4, +5, and +8. Not all the time you have to organize them. It's fine if you don't. The range are the y values. So the y values in this case are 5, 6, 8, 7, and 0. And again, if I want to organize them in increasing order, it's going to be 0, 5, 6, 7, and 8. Okay? So now I have to determine whether or not this relation is a function. In order for a relation to be a function, what's really important is to pay attention to the x values. In a function, the x's cannot repeat. So already here I have -4 and -4. The x's do in fact repeat, therefore this is not a function. Directions. Look at each relation and write down the domain, range, and whether or not it represents a function. So in the first example, we had a list of ordered pairs. In this example, we have basically a t-table or a table of values. And notice that we have the x's and we have the y's. So our job is to write down the domain. So the domain in this case are going to be all the x values, -4, -2, 1, and 3. The range are going to be the y values, 5, 8, 12, 15. And now we have to determine whether or not it represents a function. None of the x's repeat, therefore, yes, this is a function. In this example, we have not a set of ordered pairs. We don't have a table of values. Instead, we have a graph. So that's another way that you can represent a relation, is through a graph. So one of the things that we can do is actually look at the graph and identify the x and y coordinates. So I'm going to go ahead and color in blue the one that we are working with. This is the point -2, +3. This right here is the point 1, 3. This one is 0, 1. And the one below is -1, -2. So those are the ordered pairs. So now that I've written them, if you remember, the domain are your x values. The x values are -2, -1, 0, and 1. The range are the y values, -2, 1, and 3. And there are 2 3's in the range. I don't have to write them twice if they repeat. Now my job is to check to see whether or not this represents a function. So the answer is yes, it is a function. Why? Because none of the x values repeat, okay? Later on, we're going to talk about what's called the vertical line test, which is a way for us to look at any graph and determine whether or not the graph is going to represent a function. And the way it works is I should be able to draw a vertical line anywhere on the graph, and it is only going to intersect the graph at exactly one time. So just for the sake of illustration, let's take a circle, let's take a parabola, let's take a diagonal line, let's take a cubic function, and a horizontal line, okay? Do any of these pass the vertical line test? If I draw a vertical line anywhere through this circle, you're going to notice that the vertical line intersects the graph at exactly 2 times. So no, this is not a function. A parabola is a function because no matter where I draw that vertical line, it's only going to cross the graph exactly 1 time. This diagonal line is also a function because no matter where I draw this vertical line, it only intersects 1 time. The same thing for this function, the same thing for a horizontal line. However, if I have a vertical line, vertical lines are not functions because if I were to actually put a vertical line over this vertical line, it's going to intersect infinitely times. It touches the same line infinitely many times. So therefore, no, it is not a function. What you see in front of you right now is called a mapping. A mapping is when you have these ovals. On the left, we have the domain. This is the range. Notice a mapping, what's really important about it are the arrows. Without the arrows, we don't know what relationship exists. In this case, I know -4 is paired up with +2. So I'm going to write that down. -4, +2. I also know +6 is paired up with -5. So I'm going to write that down. +6, -5. And +6 is also paired up with 1. Okay, so this is my relation. What is my domain? My domain very easily is -4 and 6, and it's nice because in the mapping it's kind of already organized for us. I can already tell these values are my domain, and the same way my range is -5, 1, and 2. So right here, this is my range. Does this relation represent a function? And the answer is no. Because the 6 repeats twice, this relation does not represent a function. Remember, the x's cannot repeat in order for this to be a function. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.